So here is my function. And these problems are a little bit long, so I recommend, I gave you like half a page, but you'll either need to write small or you might need a sheet of notebook paper if you write big. We are going to do everything on this problem. So everything that we have done so far. First thing, I want all the critical points. How do we find critical points? First derivative, set it equal to 0. So, we could multiply this whole thing out to do the first derivative, but I'm not going to. I'm going to keep it as it is. So, to do this derivative, we'll have to do a product rule. So, derivative of the first one, so the 2 comes down, inside stays the same, subtract 1 from the power, so it's just a first. Derivative of the inside is just 1, so we're good there. Times the second, plus the first, times the derivative of the second. What's the derivative of x minus 2? 1. Okay, here's why I like to keep it in factored form like this. Because to find the critical points, we have to factor it in anyway. Right now I have 2 terms. What do both of those have in them? An x minus 1. If I pull out that x minus 1, the first one we are left with 2 times an x minus 2. Second one I have 1 times 1 of the x minus 1s. So we multiply out. Get x minus 1 times 3x minus 5 for my first derivative. So now my critical points, what makes that 0? 1 and 5/3. Okay, how do we find increasing and decreasing from there? Sine line. So we plot the 1, we plot the 5/3. So smaller than 1, maybe a 0. In between them, let's see, 5/3, like about 1.5. And bigger, maybe a 2. Plug these into the derivative. If you put in a 0, you get a negative times a negative, which is positive. Put in a 1.5, that's positive and negative, so negative. Put in 2, positive and positive is positive. So this graph is increasing from negative infinity to 1 and 5/3 to infinity. Decreasing in between. Okay. Local and absolute maxes and mins. So that's based off this first derivative, right? To find absolute max and mins, we have to have endpoints. Did I give you any endpoints here? So I can't even do the absolute. We're just finding local maxes and mins. So if you went from increasing to decreasing, what happened at 1? Local max. Where do you plug it in to get the y value? The original. So if I put a 1 into the original, we get 0. At 5/3, you went from decreasing to increasing, so that's a local min. If I put 5/3 into the original, 2/3, 49, negative 4/27. Okay, so we did critical points, increasing, decreasing, max and min. Next up is inflection points. How do you find inflection points? Second derivative. So here's our first derivative. Second, you could FOIL that out. I'm just going to do product rule, it's not that bad. Derivative of the first is 1 times the second plus the first. Derivative of the second is 3. So if we multiply that out, we get 6x minus 8. Inflection points, you set that equal to 0. So 8 over 6 would be 4/3. We do plot these on the graph, so it is going to be useful to have an ordered pair for that. Eventually, we could go ahead and get it right now. If you just plug 4/3 into the original, negative 2 over 27. Is that what you guys got? Okay, then concavity. So we do a sign line for that inflection point. So smaller, maybe a 0, bigger, maybe a 2. Where do we plug those in? Second derivative. I want to know when it's positive or negative. So if we put in a 0, 0 minus 8 is negative. Put in a 2, 12 minus 8 is positive. So this graph is concave down from negative infinity to 4/3. Concave up 4/3 to infinity. Okay, so I found everything. Now I asked for a graph. So let's plot our maxes and mins. We have 1, 0 is a max, 5/3, negative 4 over 27. Our inflection point was at 4/3, negative 2 over 27. So it's right there in the middle of that. I put an X for my inflection point. Okay, until I get to that X, my graph is concave down. That means it's curving downward. So if it's increasing, it looks like that. If it's decreasing and curving downward, it's going to look like that. But it's one of those two options. We know that our function, until we get to our first point, is increasing. So it's, until I get to here, it's increasing but curved downward. So it's going to look like this. Okay, we still have to be curved downward until we get to the X, but if you see, between my max and min, my graph is decreasing. So now I'm decreasing and curving downward. And very slight change, now you've got to hit this point. That's why we mark it with an X. It's not an obvious change. And then after that, my graph is concave up, so curved upward and increasing. So it looks something like this. Not perfect, but that's close. We've got the right general shape for our graph. What questions do you guys have for me? Trying to decide if I want to do the last. I think I'm going to save the last one for Tuesday, because we're just practicing a little bit each day. So this is our stopping point for today. You do have a few book problems tonight. Only one of them requires you to draw, do everything like that. So the first one is it's just asking you to find everything, maxes and mins, increasing, but not actually graph it. Number 12 kind of describes the graph and then asks you to draw it. Or maybe that's 25. Anyway,